So we have reached section 2.3, which means we're going to talk about properties today. And I've written down some information up here. Basically, we're going to make a chart. And on this chart, we're going to list the property. You're going to know what it is and what it is for each individual thing, addition and multiplication. There are two different properties for each title. So you have to know whether it's for addition or whether it's for multiplication. Sometimes they look completely different, and sometimes they look almost exactly the same. But you have to be able to tell whether it's for addition or for multiplication. You also have to know what those properties do. And basically, if it's a property, that means that it's going to end up being an equal statement on both sides. In other words, it's always true. So, in order for the addition property of identity, identity is the first one we're going to talk about. In order for it to be the addition property of identity, that means it's going to have to add. And the identity property is when it starts out as it ends up. It has to be the same thing. Whatever it starts out as is what it ends up as. So if I wanted to start out with A, I would have to add something to A so that I always end up with A. Well, of course, if I'm going to add something to A and end up with A, the only thing I can add is 0, which makes that 0 pretty important. We call that 0 the additive identity. I don't know if you can read that because it's so far away or not, but that's what we call it, the additive identity, and it's just that 0. For multiplication in the identity property, if we start out with A and we want to multiply it by something so that we end up with an A, the only thing we can multiply that by is a 1, which is why we call the 1 our multiplicative identity. Multiplicative identity. That takes care of our identity property, which is basically whatever it starts out as is what it ends up as. The next one we're going to talk about is inverse property. Your book does not talk about inverse property here, but I'm going to go ahead and talk about it here because I want you to get them all out at the same time. So for inverse property, that means it has to equal the identity. See, we just talked about what the identities were. So now it has to equal an identity. So if I start out with A and I want to add something so that I end up with that identity, what can I add to A to end up with 0? And that's going to be negative A. So when you end up adding the opposite to get 0, that's the additive inverse. For multiplication, it's different, because we're going to want to multiply this by something to end up with 1, because that's what our identity was. So what can we multiply by A to end up with 1? It's going to have to be a fraction to cancel out that A, so it's 1 over A. So A times 1 over A, or multiplied by our reciprocal, is what gives us a 1. When we're talking about the associative property, the associative property means that your parentheses are going to move. Who you associate with changes. So in the first side, I have A plus B plus C is equal to A plus B plus C. My parentheses move places, but my letters all stayed in the same order. It's still ABC, ABC. That's for addition. because they're all pluses. If I wanted it for multiplication, I'd have to change them to all multiplication signs. So my parentheses move. Who it talks to doesn't change. Who they talk to is what changes. They don't move. The letters stay in the exact same spot. Parentheses move. For commutative property, it's the letters and numbers that move. So if I had A plus B, my letters would have to move around. So that's the same thing as B plus A. Now you know that that's true. This is why that's true, because we have this property. That's how we can say that this is true, because there's a property there. It's our commutative property. It means the letters and numbers can move around. It's okay in addition. It's not okay in subtraction. That's why subtraction isn't on our list. It's okay in multiplication. It's not okay in division. That's why division didn't make the list. Those are some of the basic properties that you're going to have memorized. Now, there are some other properties we need to talk about. They don't have a specification for addition and multiplication. So I don't break them down that way. We have some properties of equality. You have the reflexive property, which says R is equal to R. And they use R because it starts with reflexive. Same thing if A is equal to A, B is equal to B, C is equal to C, etc., etc. You have the symmetric property, which says if A is equal to B, then B is equal to A. If it's one way, then it has to be the other. And then you have the transitive property. That has an N in it. I spelled it with an I, but it's an I. Which says if A is equal to B and B is equal to C, then A must equal C by the transitive property. Now, all these are properties you need to know. These really come in handy in geometry, but they're also for algebra. However, the one you're going to use the most, the one that is always around, the one that will follow you from now until the end of your days, is the distributive property. Oh, it didn't show up. Where you distribute something. To distribute something means you pass it out. Give some to everybody. So if I have A and I want to distribute to B plus C, then I have to give some of A to everybody. Same thing happens if it's in the back. Doesn't matter which way it goes. It's still called the distributive property. It also works if there's a minus here. Because if there's a minus here, then there's a minus there. Same thing here. It works if there's a minus. Look on page 61. The classwork exercises, numbers 1 through 6. Pause the tape, and I want you to do numbers 1 through 6 really quickly to figure out which property they're using. Okay, so for 1 through 6, number 1, it says 3 plus, then it's got the bracket 5 plus negative 2 is equal to 3 plus 5 plus negative 2. What changed from one side to the other? Well, the bracket went from being around the 5 and the negative 2 to being around the 3 and the 5. So when it moves, when your parentheses move from one place to another, that's the associative property. And are they multiplying or are they adding? Okay, they were adding. So that's the associative property of addition. Number 2. They have 6 times 13 equals 13 times 6. The letters moved, so that's the commutative property. Of multiplication, because they were multiplying. I can spell, sort of. Then for number 3, they went from having 4 parentheses 3 plus 7 to 4 times 3 plus 4 times 7. They distributed. You can't say if that's of addition or multiplication because the distributive property does both at the same time. So we don't have to write either of those. We just write the distributive property. Technically, they distributed a 4. That's all you need to know. For number 4, they have 1.4 plus 0 equals 1.4. What it started out as, it ended up as. So that's the identity property. Of addition. It is not the additive identity because 0, just that number 0 is what your additive identity is. Number 5. They have 8 over 7 plus 4 over 9 times, 8 over 7 times 4 over 9 times 7 over 8 is equal to 8 over 7 times 7 over 8 times 4 over 9. What changed? The numbers moved around, right? The fractions moved. So that's the commutative property. Of, they were doing multiplication. And then for number 6, the parentheses go from being around the negative 1 plus 9 to to being around the 4 plus negative 1. All the numbers stayed in the same order, so that's the associative property. Of addition, because they were adding. Now we need to practice a little bit with the distributive property. Now I know you've done this before. But look at problem number 7 down at the bottom. It says simplify by using the distributive property. And then look at problem number 21 on the next page. It says rewrite each expression using the distributive property. There is a difference. For problem number 7, when you are simplifying, sorry, I'll make a big mess. For problem number 7, when you are simplifying using the distributive property, that means they want you to do your distribution first. So that's 10 times 500 plus 10 times 13. So that would be 5,000 plus 130, so that's 5,130. Now we could have gotten the 5,130 a simpler way, just by adding and following our order of operations. But they didn't tell us to follow the order of operations, they told us to use the distributive property. We need the distributive property because we can't always follow the order of operations. Sometimes there's going to be letters in here, and when there are letters you can't follow an order of operations because you don't have all the numbers. For problem number 21, however, it says to rewrite each expression using the distributive property. So that's going to be 2 times 3x minus 2 times 11. Technically, I've rewritten it using the distributive property, but I want you to go ahead and simplify it. So 2 times 3x is 6x, and then 2 times 11 is 22. And that would be your answer. So we can't combine those because they're not like terms. We'll get to that in the next section. But since they aren't the same, we can't put those together. Chances are the back of your book may want you to stop here, and that's okay. You can check that when you're doing your classwork. But when you are doing the simplifying, remember that means you have to get it as small as it can go. So you need to make sure you get that one number if all you have are numbers in your problem. When you get letters, then you're going to have one letter left in your answer. Now, I know you know the distributive property, that this is not new to you, so I'm not going to have you do a whole bunch of stuff with me and then turn around and do a whole bunch of stuff in the classwork and then turn around and do a whole bunch of stuff in the homework. We're going to get it all taken care of at one time, I hope. So, I'm going to go ahead and assign your classwork. Practice exercises. On page 61. Numbers 2, 6, 10, 16, 18, 20, 22, and 26. Make sure you pay attention to the directions as we said. And then your homework, when you're done with that and you've got it all checked, same practice exercises. numbers 3, 9, 13, 15, 17, 19, 21, and 25. And I'll see you in the next section.